Okay, so for number 2, on May 12th, 2008, the U.S. Postal Service reissued the Forever stamp. It is always valid on standard envelopes weighing 1 ounce or less. The cost of the first class postage stamp was 4 cents in 1962, and then it was 44 cents in 2010. So it gives us some variables to use over here. So S is going to be the cost of the stamp, and then T is going to represent the number of years after 1962. So in general, we know that our function has to be S of t equals S sub 0 times e to the kt for an exponential growth. We do know the original cost. It's going to be 4 cents. So I'm going to substitute that in for the initial cost. What we don't know is k. So to find k, we're going to use this information here, the fact that it cost 44 cents in 2010. So what we need to do is calculate the amount of time that has passed in 2010 since 1962. So that's going to be 48 years. So when time is 48, the number of cents is 44. Then we'll solve this. So to solve, first you're going to divide both sides by 4. You'll get 11 equals e to the 48k. Then you'll take the natural log of both sides, leaving you with the natural log of 11 equals 48k, and then you're going to divide by 48. So natural log of 11 over 48 is what our k is. So use a calculator, and we're going to round to 3 decimal places. So k is approximately 0.04, so it's going to be 499, so we're going to round that up to 0.050, because if we're rounding to 3 decimal places, this would round 49 up to 50. So we can just call that 0.05. So our function, so it says write a function, is going to be S of t equals 4 cents times e to the 0.05 t. That's our function. It says what is the growth rate in cost? So all you're going to do is express k as a percentage. So if it's 0.05, we're going to say this is 5% per, and then whatever your unit of time is, it's going to be years. Predict the postage for 2014 and then 2016. So in 2014, the number of years that have passed since 1962, that's going to be 52. And then in 2016, it's going to be 54. So we're going to find S of 52 and S of 54. Okay, so if you plug that in the calculator, you're gonna get 53.855. So because we're talking about the cost of something, I think it makes sense to say this is going to be about 54 cents. I'm choosing to round up because this is an 8. But if you round down, that's fine. It's in between 53 and 54 cents. Now, for the second one, we'll plug in 0.54, or 54 rather, and we get 59.519. So I'm again going to choose to round up, so that's going to be about 60 cents. So just on your quiz, if you have to round in a similar way, that's totally fine. You can choose 53 or 54. Just show me this number so that I know what your original number was before you round. Now, if this was in dollars, we would round to the nearest cent. So we'd round to 2 decimal places. But since the question was in cents, we don't round to any decimal places because this is already technically 2 decimal places because it's $0.54. Okay, next one. Hardy Bank advertises that it compounds interest continuously and that it will double your money in 12 years. What is the annual interest rate? So you're basically solving for K and it gives you the doubling time. So remember, doubling time times K equals the natural log of 2. So if we're given the doubling time, then we can find K by taking the natural log of 2 and dividing by the doubling time. So our K is going to be natural log 2 over 12. Use your calculator and round to 3 decimal places. So I get 0.0578. So annual interest rate is going to be about 5.78%. Okay, so because it's asking for the rate, express it as a decimal, or express it as a percentage instead of as a decimal. Okay, tuition at Rollins College was $100 annually in 1885. It was $53,000 in 2014. Assume this is exponential growth such that, all right, we have this model here. So we're gonna first make the assumption that 1885 is gonna start us off, which means the 100 is going to be our C sub 0. So in general, cost as a function of time is going to be equal to the initial cost times e to the kt. We know that the initial cost was 100. We are going to substitute some values in here. 53,000 and 2014 give us some other points. So we're going to calculate how many years have passed in 2014 since 1885, and I get 129 years, which is a really long time. So after 129 years, tuition is 53,000. So plugging those in, I can solve for K. So first, divide by 100. Take the natural log of that, and then divide by 129. Okay, so this is 0.048. So after the 8 is a 6, so we'll round up to 0.49, making our function C of t equals 100 e to the 0.049 t power. So that's our function. The growth rate, that's K. We're just going to express that as a percentage. So that's 4.9% per year. Predict tuition for the year 2020. So 2020 would be 6 years after that, so that's going to be 135 years after 1885. So plug in 135 into your function and calculate. This is approximately $74,620.47. So because we are estimating a tuition, I rounded to the nearest cent, and there you go. Okay, under ideal conditions, the growth rate of a rapidly growing bunny population will be approximately 11.7% per day. When will this population double? So once again, we are looking for doubling time. We know that doubling time times K equals the natural log of 2. So if we're solving for doubling time, we can divide this by k to get the natural log of 2 divided by k is our doubling time. So if we know k, we need to make sure that it's written as a decimal. So if you move your decimal place 1, 2 to the left, we get k expressed as a decimal. So doubling time equals the natural log of 2 divided by 0.117, which is approximately 5.924. So I'd say about 6 days. Okay, we are saying days because the rate was written in days. So you just want to pay attention to the units of time. Okay, guys, I hope that was helpful, and sorry I'm not here. Do your best on the quiz. If everyone fails, you'll get a curve. Okay, bye.